are investigating how pH affects the rate of reaction of amylase by timing starch breakdown at different pH values. Enzymes catalyze reactions by binding substrate at the active site, and pH can alter the charge and shape of the active site. Our prediction is that amylase rate will be highest near neutral pH and lower at more acidic or alkaline values. The independent variable is pH. The dependent variable is reaction rate, calculated as 1 over the time to lose the blue-black iodine color, and control variables include temperature, enzyme concentration, substrate concentration and volumes, and mixing and sampling intervals. The equipment required is amylase solution, starch solution, pH buffers covering the chosen range, a water bath or beaker to hold a constant temperature, droppers or pipettes, a spotting tile with iodine, labeled test tubes, a thermometer, and a timer. First, we set the water bath to a constant temperature, such as 37 degrees Celsius, allow all reagents to equilibrate, and place equal volumes of starch and buffer into each labeled tube. We add an equal volume of amylase to the first tube to start the reaction, start the timer, mix quickly, and at regular intervals such as every 10 or 20 seconds, we transfer a drop to the iodine tile to test for the presence of starch. When a spot no longer turns blue-black but remains the iodine color, we stop the timer and record the time for that pH, and we repeat the process for each remaining pH. We repeat each pH trial at least 3 times and calculate a mean time, and we convert times to rate by calculating 1 divided by time in seconds. We plot a graph of reaction rate against pH, observe the peak that marks the optimum pH for amylase under these conditions, and compare the fall in rate at more acidic and more alkaline values. To improve validity, we keep temperature constant, use the same total volumes and concentrations, standardize the mixing and sampling interval, fresh iodine and clean droppers for each tube, and avoid contamination between spots. We conclude that pH affects amylase activity because changes away from the optimum alter the ionization of groups in the active site and substrate, reducing binding and catalytic efficiency, and very extreme pH can denature the enzyme.